one, Manpreet couldn't be here, so we'll watch his video. This is hard drive Lifeguard.
Everyone, my name is Manpreet and I'm working on hard drive Lifeguard project for Hackathon. To give you a brief background on the project, while I work with developer community, I see that most of the quality time is spent on operational burden while solving problems for both applications and infrastructure side. And I strongly believe that this can be solved using artificial intelligence techniques. Traditional machine learning techniques required a lot of label data to perform classification. On the other end, NewPick, which can perform online learning and perform predictions and anomaly detection, is a much better choice here. To brief you on the architecture, data ingestion takes place through different collectors used on H-based clusters. Smart attributes are collected into a common database from where it is fed to the algorithms to perform anomaly detection. Now I will take you through the dataset and demo. Dataset consists of 64 attributes, smart attributes, and this data is collected from one of the universities from multiple drives. Each line in data section contains data from one smart read, temporal in nature with last column being 1 or 0, which is a class attribute, defines failed or good drives. If I go to Lifeguard runner, the first thing I do is I select the feature vector using Z-score technique. I split the data into good and bad. Then new good and bad models are created. The idea is when the new data comes in, it goes through the good model and the bad model, and the anomaly scores are calculated. Based on the anomaly scores, the classification is then done. Find good and bad method feeds in sample data and tries to see what is the anomaly score. Run hard drive anomaly plots the graph to see whether the anomaly detection happens. Let me quickly run a demo to see that. And here we see the data is being fed into the NewPick models, and this is where I have inserted anomaly data where I'm predicting failures, and the model is able to predict the anomalies because it earlier doesn't know about it. While slowly it starts learning, the anomaly score drops down and it should basically go to 0. And that's exactly what is happening here, as we see. There's another small spike that I've added into the data to perform testing, and it again detects the anomaly score, and as expected, the anomaly likelihood drops down. The data that we printed for sample data can be very clearly seen that it started learning after a while, and the anomaly score becomes 0 here. This is what I could achieve, and I would like to thank Numenta community for helping me out to achieve this. And I hope from alpha and beta stage, I'm able to get this onto gamma and prod someday. Thank you very much.
Thank you, Manpreet. So as I was watching this demo video, it struck me that when he described how he was trying to do this classification, that he was approaching it the right way. Train a model on all the good drives that never failed, train a model on all the bad drives that did fail, and then send the new data into each one and see which one has a higher score. But the charting still confuses me. I don't really understand what he's charting there. I tried to work it out with him on the post, and this could be worked out with probably a communication here, but I'm still sort of confused about whether he seems to think he got good results, but from the charts I don't really see that. So that's my takeaway.
Yeah, I had the same confusion as well. It wasn't clear to me how it mapped to the first thing he was saying. And is it really working well or not?
Is it really working?
And I didn't understand what the data was, actually. I couldn't.
Well, there was a bunch of different fields of data that he got from some public data source that ran a bunch of tests on hard drives, and I don't exactly know what the fields were, but they're all scalar fields, and some of them failed after being put under stress.
Is he building models for each one of those?
No, he trained one model on all of the drives sequentially that failed, and I think reset after the failure. and he trained another model on all of the drives of the past.
Yeah, but.
And then he's trying to
I didn't
classify them
understand-
based on their
I didn't
anomaly
understand
score.
what the temporal data was. I didn't-
Well, it's these scalar values over time that are emitted from the drives as they're running. I don't know exactly what they represent in the drive,
So
but
I
they
would
do
need-
have some indications
Then I would
of
need a
health.
different model for each scalar value,
That, or I think he's using multiple fields in one model.
but he had a lot, so.
They're called SMART. It's a profiling standard, I guess, for hard drives. I don't know much about it, but
So
I
I
was looking
think
up Wikipedia.
Like
There's a ton of
soft error rate
fields.
stuff.
Yeah, I believe I advised
Having to
him
retry a bunch.
to pick one or a small handful of those values that were changing the most, or at least most applicable to the problem, when he did and looked through it, with his own eyes, and just create models with that small number of fields.
Yeah.
Yeah.
I think in general, these are kind of great kind of problems, but often you need to spend as much engineering time verifying that you're getting valid results, because it's very hard sometimes to tell. You need to really spend engineering time on that. So he might have done that, but I couldn't tell that.
One thing I noticed is that the frequency of the data is 2 hours. It seems like for hard drives, you would want much tighter frequency, or am I wrong in that?
No, it's the cumulative errors, let's say, during a 2-hour period.
Oh, okay.
So, when something goes wrong, you'll get a burst of errors, and that's reasonable aggregation.
Yeah, I'm not familiar with the data source.
I think this is a nice application idea, because hard drives are really critical, mission-critical devices, obviously, and you could imagine there would be fluctuations in some measurements before a catastrophic failure. And so to the extent that you can detect those fluctuations, and I could imagine they would be temporal in nature, not spikes or anything like that, but if you could detect that before a hard drive failed, that could be pretty important.
Agreed, there's potential here, yeah.
I think
Yeah,
there's
replace
there's
the
some
drive
interesting
before it.
So I'm
potential there.
familiar with what SMART collects. So some things are failure rates, and if you see discontinuity in failure rates, then it's worth learning about. Other things, though, do have temporal drift, like ambient temperature. And in fact, there you probably do want to use a hard threshold, and not
Yeah.
something that tracks.
Yeah, so it's a
you
combination.
need both.
Yeah.
Okay.
Okay. Go to the mic, please, to ask a question.
Can you comment on the strategy that was used for creating two models and comparing their anomaly scores, which is assumedly what was done, as opposed to a single model?
Well, you don't necessarily need two models. You could just train one model on all the healthy drives, and then classify them based on some anomaly threshold that gets achieved.
I think in general, you could build one model, and if you built a model that did classification, so you'd have to have labeled data, and we've done this internally, and there's not a lot of good tools, I think, right now available to make it easy for other people to do that. So it's totally capable of doing that. The HTM algorithms are totally capable of doing that, but we haven't really exposed it. And what we found out, since we focused on anomaly detection, we found that people were very clever, and they were using anomaly detection to do classification like this. And it seems to work pretty well. So is this really the beautiful way of doing it? No. Does it work? Yeah. And like someone else thought of it, and now a lot of people have done it. So, but ultimately we can do it. I don't know if we can do a better job, but we can do it with a single model and classification. But it's just not as easy to do right now. This is easy to do.
Yeah, agreed. All right, thank you, Manpreet.